Hi everyone. As Mohit said, I'm Tulshekar, so I'll take you through the session today. Right. So what we are actually going to talk about today is Cassandra and Hbase. So let's understand the most popular ones. The most popular ones in the NoSQL world are Cassandra, Hbase, and Mongo. Okay. So we're talking about three of them, right? So Cassandra naturally is simple setup, maintenance, and code, because when it comes to maintenance of Cassandra, the administrator has to do nothing. Most of the things are automatically done. So if you want to scale up or scale down, remove a node or add a new node, and etc., it's very, very fast in the case of Cassandra because it provides you a simple tool which can help you to do that. And you don't have to really worry about resyncing, balancing, distribution of data. All these things are actually automatically done. You want to do it manually, you can always do it. And absolutely provides very, very high velocity of random reads and writes compared to the other NoSQL systems because of the columnar storage capability and its distributed decentralized architecture. Okay. Flexible sparse wide column requirements, where you're talking about more on capability to increase your columns for a specific type as and when you need. On a need basis, you can alter your schema. It absolutely have no restrictions on that. The only problem, rather I would say it's not a problem, but it is only suitable for a case where secondary index needs are less, which means you have an absolutely denormalized information, which is all information is sitting associated to serve a specific query is sitting in one single table and not goes across multiple tables to get to serve a specific client query. So assuming basically non-group by kind of models. People who are very familiar with RDBMS can understand what a group by means. So non-group by kind of systems, Cassandra is absolutely suitable. But if you have an application which has a requirement of group by kind of functionality, Cassandra is probably not a right system to choose. It supports secondary indexes. It doesn't mean that it doesn't support, but when you are bringing in secondary indexes, its internal overhead becomes so high that the overall performance of the system comes down. The more secondary indexes you use, the less the performance. So you can use Cassandra in those cases where you have less secondary index needs, where you want a very simple setup and maintenance, very high velocity of random reads and writes, and wide column requirements. All these things were sort of very, very well fit into time series or data where consistency is not very, very important. Okay. An example would be Twitter, where we're talking about very, very massive scale and high availability. A simple thing, imagine the scale of these, right? So if, say for example, Angelina comes out and tweets saying that if anybody who retweets what I've tweeted, I'll have a date with him, assume the number of hits that you will get on the Twitter application. It will be millions and millions of people doing it at the same time. Okay. So it should be able to handle that kind of a scale. And when it comes to availability, naturally, there are millions of people tweeting on millions of topics at the same time. So it has to be available and make sure that people don't have a bad user experience. Okay, so there is a couple of questions. Is non-group and no joins? Yes, absolutely no groups, no joining in Cassandra. What all features are to be looked into when checking whether the system is consistent or not? See, it's like this, right? What is consistency? Consistency basically means, see, for you, I mean, the properties that we talked about, right? The set of properties. So first thing is, say, for example, if a system has to be highly available, which means that if you have multiple clients querying for something, and even in case of a failure, you should still be able to service your requirements, which means you should have multiple replicas within your system. So when you have multiple replicas, the consistency purpose, what you would need is basically all replicas are absolutely in sync every time a write happens, right? So whenever I'm doing a write operation, okay, I can actually give you an example of Cassandra, and because Cassandra gives you a tunable consistency. So in Cassandra, if you say if I set my tunable consistency as the highest, that is all have to be properly in sync, then every time I do a write, right? If every time I do a write, it writes it to one replica, but the write does not reply with come back with a success till all the other replicas which are there in the cluster are absolutely in sync with the data. So that sort of overall your latency of the write automatically increases because Yes, your data is completely, it made it consistent behind the scenes. Before you return a success for your write. So that is what is the consistency concept. So you can actually obtain your feature, your consistency behind the scenes, basically, which means that every request comes from client application results in the same result going back. Okay. Okay, let's get to the next one. So where not to use Cassandra? Absolutely no. In the case of a lot of group by second indexes, transactional data, relational data, stringent security and authorization needs, never use it. Okay, and dynamic queries. Since Cassandra is basically the query modeling concept, where you're talking about you model your storage subsystem using queries. So first of all, when you're doing a modeling, you actually look at all the most commonly used queries. Then you model your data. Then you prepare your data model based on that one. Since it's a query-based modeling system, dynamic queries are very costly in Cassandra kind of storage subsystems. Okay, wherever there is a dynamic query requirement, don't use Cassandra. I mean, you can use, but you'll get worse performance probably than the other systems. Okay, where to use Hbase? It's basically, I mean, pretty optimized to reads, and it is probably one of the best systems used for a MapReduce kind of model, because it was built for such kind of a systems where it was in conjunction with to work well with Hadoop. It was built to work with Hadoop, so it has where applications have good consistency requirements, it could be used, but we're mostly doing range-based scans, because in Hbase the database storage is actually done in blocks of data. So your range is much bigger. So if you're range-based scans, you might end up getting it from a single memory block. And the size of the memory block is adjustable. You could actually create this block. It stores data as raw blocks. So that data, if as long as your range query falls within that block, it can be just obtained once from one single node. So the distribution is based on blocks. So that's why it's good for range-based scans. Wherever you have range-based queries and all, Hbase works really well, and it works really well in cases where you have MapReduce kind of an application, because it was always built with MapReduce in mind. So MapReduce, how it happens is basically you pick up the entire block at one shot and run map or reduce functions on those block of data. So in which case you don't want really to go and search and pick up small data and then run on MapReduce on it. You would rather pick up a huge chunk and run MapReduce, which is much faster and better and more efficient. So Facebook naturally uses it for user statuses, photos, chat messages, etc. The Facebook Messenger actually works on Hbase. So where consistency is very important, because it gives automatically consistency because of the master-slave model, which it has at the base, and naturally the scale and is available out of the box, because you can just keep on growing by adding a lot of what we call it as the name node and the slave node sort of thing. So they have basically a controller node and worker nodes kind of a thing. So you can actually keep on adding more worker nodes to actually scale it very comfortably. Okay, and then I think Hadoop in this version 2 actually even provides you some capability of adding a cluster of name nodes, and it's not just single, and it's more of active cluster name node concept that's available, which sort of gives you a level of high availability, but it's still a class of servers. So if that class of servers for whatever reason is down, it will create availability issues. Okay. Which of these NoSQL, okay, let's come back to a question. Which of these NoSQL DB works better within encrypted data like HIPAA or etc.? Okay. See, I mean, all of them support encryption to some extent, but preferably Cassandra is not a right system for encrypted data, because I mean, there are actually a set of for HIPAA and all, probably I wouldn't be able to answer it out of the box, but there are actually few systems where more of analytics kind of applications, or more of people where they are using a lot of where you're doing some trending charts, etc. Again, as I said, right, it's more something which data which changes with time. So only in those cases where we heavily use NoSQL or Cassandra systems. Cassandra as an example, but yeah. For booking of appointment, Cassandra is a good choice. I don't know what you mean by appointment. See, for searching availability of appointments and something which can change over time, Cassandra is a good system. But once it is booked, I would rather not really worry about storing that in Cassandra. Basically, you can form a combination of systems. For time series kind of queries and etc., you could actually use Cassandra. But for more reliant stuff, you could use a consistent system like Mongo or Hbase, etc. for the final storage. So you could have a combination of both to create an appointment or a booking appointment application kind of a thing. Similarly, every system out there uses like that. For example, Facebook uses Neo4j for all your graph searches, but when it comes to Messenger, it uses Hbase it uses Cassandra for a lot of internal data which it stores, etc. So there, it uses all three of them to some extent. But they're all meant to be for specific type of applications. Which database is best suited for Indian Railway? Okay. I mean, I would probably go with Mongo to some extent to say, but I don't know whether even that is scalable and can meet the requirements of that one. Okay, let's complete this and then we can talk about these questions a lot in detail. Where not to use Hbase? Wherever you need full table scans because it's actually stored in blocks of data, and if the data goes across blocks and etc., which will become really painful and performance-wise it will become bad. So data to be aggregated, rolled up, analyzed across rows, all these kind of cases, you don't really use Hbase because, as I said, Hbase is right for map reduce kind of a job where you have a set of data and you want to run a specific map or a reduce function on those data and just get the results. A lot more independent. So independent pieces of data running each of them separately. But when you have to do aggregation, roll up, analyzed across rows, and etc., Hbase really performs bad. It's not a suitable system for that. Okay. If you compare sort of thing, right? Hbase naturally is distributed and scalable big data store. Naturally, all of them to some extent, but so comparing wise, strong consistency, Hbase, built on top of Hadoop distributed file systems. So very much use Hbase in a situation where you're talking about more of map reduce applications where you have more consistency requirements, very strong consistency requirements like Facebook application, like Facebook messengers basically. Hbase is the right one. Now coming to Cassandra, incremental scalability, eventually consistent kind of models, more of time series applications like travel portals, and wherever you, the questions like feeds and etc., you would use Cassandra. Now coming to Mongo's. Mongo is basically again a sort of an absolutely, it gives you a schema-free model, but it's a good replacement for RDBMS. So if you want to replace an RDBMS with an NoSQL system, Mongo probably is the ideal choice to start with. The only problem with Mongo, as I said, is again has issues with all these things really work. So if you look at any of the systems, right, there's a lot of practical data on read and write latencies. So there is a practical experiment which has been done. So if you look at the read and write latencies on these kind of stuff with respect to speeds and etc., Mongo and Hbase sort of work well only up to a specific limit of data. Beyond that limit, they sort of degrade in their performance. Say for example, about 32 or 64 GB of data onwards, Mongo and Hbase somewhat come down on the performance wise. Cassandra sort of gives a consistent performance beyond that, and even beyond that, when the amount of data increases to petabytes and petabytes of data, Cassandra sort of gives you a very good performance at very high volumes of data and high read and write indicators. So that's where Facebook actually uses Cassandra. So where there are situations of writing too much of data into the system and very high volume of reads and writes, and when the scale goes really high, they use Cassandra. For more consistent applications where you're talking about Messenger and etc., they use Hbase.